So this is our ICP 7. We begin by importing all the necessary libraries up at the top. Then we load in the MNIST dataset. It's inherent to the Keras library, so we don't have to go to an external source. We get the dimensions and then reduce the dimensions to save memory. Here we print out some of the example text so we can see they are handwritten digits. Here we get the test size, and then here we're setting parameters. So we just set default parameters for batch size, number of epochs, test train split, and then we have one channel for black and white images, and our latent dimension is 2. Here we're getting the input, or we're reshaping the data to get it in the necessary format for the variational autoencoder, and then we're normalizing it. And here is our encoder. So first we have the input, where we use the input shape to tell the encoder what the input is. And then we decided to add 2 additional convolutional layers. We did this because we think that these convolutional layers will further decrease the size of the data and encode the data further. And with this variational autoencoder, our goal is to create brand new samples. So by further encoding, we can get maybe some more variation in the output and some distinct images that will be further from the training images. So the convolutional layers decrease these layers, and the normalization normalizes it. We then flatten it, use the dense layer and another batch normalization layer. Down here we're defining our loss function, so we need to get our function in the form of a differentiable function. So this is what this is doing down here. Otherwise, our machine won't be able to learn. And same here, we are further defining how we are setting up our loss function. And here's the definition for the encoder. Down here, we again need 2 more convolutional transpose layers to basically undo what we did the encoder. And then we have the input, which is the latent dimensions, which is 2. And then this conv shape is something that we gathered up here. And then finally, we output with the filters equal 1, and then sigmoid activation. We then get the decoder model, compile the decoder and the encoder together to get a variational autoencoder. And then we run our autoencoder. So we got a validation loss of 0.19. And then finally, we visualize it. So we can see this pretty cool graph where the numbers kind of run together, and we can see some example outputs.